we're going to look at heat changes calculated from temperature changes. So temperature and heat are not the same thing. An increase in a temperature when the object is heated really depends on the mass of the object, the amount of heat added, and then the nature of the substance, whether it's solid, liquid, or gas. We use Q equals mc delta T, and this equation is given to you. So Q would be the heat, M is the mass, C is the specific heat, which tends to be given to you, and for water it's 4.184 joules per gram Celsius, and that's in your reference tables. And then here we have the change in temperature. And to find the change in temperature, you would do the final temperature minus the initial temperature. So that change in temperature is sometimes negative. If we want to take the mass out of the situation, then we would come up with Q equals C delta T, where this C represents molar heat capacity. So let's look at some examples. Here we have 10 grams of copper, so that is our mass, with a specific heat capacity, and so this is our C. And then we have a change in temperature. So again, we're going to take the final temperature, which would be 85, and we're going to subtract the initial temperature of 25. And so we get a temperature change of 60. Now we want to keep the same number of decimal places when we add or subtract as the fewest in the measurements. In this case, they both have one decimal place. And then we're looking for the heat, so we're trying to find out what Q is. Well, Q equals C mc delta T, so we're just going to multiply our values together. Mass times the specific heat that they tell us, and then times the change in temperature. When we multiply there, the grams are going to cancel and the Celsius will cancel. So the unit will just be in joules, which is our unit for temperature. We want 3 significant figures because the mass and the change in temperature have 3 significant figures. We don't use specific heat capacity because that's a true value, an actual value, and it would have an infinite number of significant figures. So the answer ends up being 231. Looking at another example, again we have our mass, we have a change in temperature, so we'll go ahead and say the final minus initial. And so we get 30 degrees Celsius. Notice there's no decimal point this time because the measurements didn't have one. And then we have an amount of heat, so that's going to be our Q. Now we can't have kilojoules, it needs to just be in joules. So we're going to use King Henry and we're going to convert that to joules. And so we would move the decimal over 3 places. To indicate that there's only 2 significant figures though, we're going to toss in the line above the first 0. What is the specific heat? So we're looking for C. Q equals C or mc delta T. So to find C, we're going to have to divide both sides by M and delta T. So we would say 2,000 joules divided by our mass times our change in temperature. And so we end up with an answer of 0.90 joules per gram per Celsius. So 0.9 joules of heat changes 1 gram by 1 degree Celsius. That is what that means. Our last example here is a little bit different. Here we have a situation where we're combining 2 substances. So we have a sample of water that's at 75, and then we have a sample of water at 15. So when we combine these 2, all right, so we have water at 75 and water at 15. When we pour them into the same container, what should happen is the 75 would decrease in temperature where the 15 is increasing in temperature. And so we should get a final temperature that is somewhere in between. Now it's not directly 50 percent of the way in between those two values, it just falls in between. And that's really because of the amount of water at each temperature. So we know that the final temperature is going to be the same for both. The other thing we know, though, is that the higher value temperature is going to have to lose heat. So it would have a negative Q value. And the water at a lower temperature is going to have to absorb energy because it's going to have to increase its temperature. So it would have a positive Q value. Now what we need to know is that those two Q values are mathematically the same magnitude. So we have to say that the heat lost is equal to the heat gained. So what was lost by the 75 Celsius water is gained by the 15 Celsius water. And since we know that Q is the same thing as MC delta T, we can set up our equation so that they are equal to each other. Because both substances are water, we can also eliminate the C because we would end up dividing by the same value. So what we have then is we have the mass times the temperature of the 75 is equal to the mass and the change in temperature of the 15 degrees Celsius. All right, so let's look at this problem or plug in our numbers. We have a mass of 35 grams, and we're going to multiply it by the change in temperature. So the final temperature minus the initial temperature of 15. And that's going to equal a mass of 15 times the final temperature minus the initial temperature. And then we just need to solve for x. So we would say negative 35 times x is negative 35x. Negative 35 times a negative 15 would give us 2,625, 15x. And then 15 times 15 is 225. And then combine your like terms. So we're going to add 35x to both sides. So 2,625 is equal to 50x minus 225. Add 225 to both sides. And we have 2,850 is equal to 50x. And then we would divide both sides by 50. And so x equals 57 degrees Celsius. And that value is in between 75 and 15. So that's a way of checking that our answer is correct.